This video is going to be about question 3 on the worksheet, DIY merge sort. So if you have not watched the dedicated video that we have for merge sort, please go and watch that because I'm not going to be giving any mini lecture in this video. Instead, I'm just going to be refreshing our memories before we jump right into the problem. Okay, so let's recall the 3 main steps in merge sort. First, we divide, then we sort, and then we merge. This is a divide and conquer algorithm. Excuse me, I honestly could have misspelled a lot of things in here because spelling is not my forte, but that's okay. Let's go. Okay, actually it's probably not okay, whatever. I'm sorry, you guys. Okay, so in this problem, we will implement merge sort using an auxiliary array. Note that this implementation of merge sort should modify the given array, referred to as R. Okay? So if we look at the skeleton code really quickly, we can see that we are given the skeleton code for 2 different functions. We have merge sort, which is going to take in a single array of integers, and we also have skeleton code for something called merge, which takes in 3 arrays of integers, referred to as R, left, and right. Okay, so I'm thinking to myself that this, well, because I know that there's, recall, right? Let's just read it down here. 1, this is the steps of merge sort. Divide, sort, and then lastly, oh, would you look at that? Merge, okay? So I'm thinking that this function, this skeleton code down here, is really just the 3rd step has been written out in a function of its own, right? So merging, there's a dedicated function for merging. So, okay, that's good to know. I'm actually going to start off by writing the code for merge sort, but I'm going to use, in my mind, I'm going to just kind of use the properties of abstraction and apply them to this merge function right here. So I'm going to just assume merge is already implemented while I'm writing my code for merge sort. Okay? So with that all in mind, if you haven't already tried the problem, please go ahead and try it and then come back and watch me walk through the solution. Okay, let's go through it together. So we take in an array of integers. Let's just put something down and pretend that this is what we're taking in, okay? Now, I hold on to the length of the array in a variable named n. And in what case do I want to return immediately? Well, what if I got in something that was like this, just an array that just contains 1, or an array that just contains 5? Well, there's nothing to sort in those cases, right? So if n is less than 2, right, I'm just going to return. If there's 1 or if there's 0 things in my array, both of those cases, there's no reason for me to go through any more code. I will return. Okay, what's next? Well, remember, the first step of merge sort is dividing. So when we say dividing, what do we mean? Well, we want to kind of split our array in half, okay? So if this was our input, 1, 2, 3, 4, I want to divide my input into 2 smaller subarrays, like so, okay? And then I want to recursively call merge sort on these 2 subarrays. So let's figure out how we can put it into code, the dividing process. Well, a good first step would be to figure out the midpoint of the array. And they've gone ahead and done that for us. They've said that mid is going to be equal to n over 2. That makes sense, right? Now, it seems like they are instantiating 2 smaller arrays, a subarray called left and a subarray called right. Our job is to figure out the size of these 2 smaller subarrays, right? When we're declaring arrays, we can put the size inside of the bracket here after saying new int, right? So, okay, fair enough. How big should our left subarray be? Well, in our case up here, we have n equals 4, and mid is going to be equal to n over 2, so mid equals 2. And to me, it seems like the left should have a size that's the same as the midpoint, right? Now, how about the right? Well, the right half should have however many leftover elements there are, right? So it should be n, right, the total number of things in the array, minus mid, which is the number that we're taking care of in the left array, okay? So that helps us in case we have a pesky little odd-numbered array, like so, right? Then we're not going to be leaving out that last element. All right, so at this point, our code has taken care of the actual instantiation and sizing of our new left and right subarray, but we haven't actually put in any numbers. So we're going to take care of that right now, okay? We're going to do 2 for loops, and our goal with these for loops is to fill in the subarrays. So for int I is equal to 0, while I is less than mid, I am going to assign I'm going to assign the, at position I in the left array, what do I want to be inside of there? Well, I want it to have the same exact thing that's inside the original array at that index inside of the left subarray, right? So I'm going to go through my for loop, and I'm going to say, okay, at index 0, I want 1 to be inside of my subarray. At index 1, I want 2 to be inside of my left subarray, okay? These are the indices here at the top. Okay, so that's done. I've done my left. Now, how about my right? How can I assign the correct elements to my right array? Well, instead of starting off at I equals 0, I'm going to start off at I equals mid, and while I is less than n, the overall size of the array, I'm going to increment I, and now for the index of right, this wouldn't work. Or sorry, I can't say this. I can't say right I is equal to array at I. Why not? Why can't I do this? Maybe pause the video and see why this is incorrect. The reason that this is incorrect is because right is a subarray itself. And so it doesn't even have an index that is mid in this case, right? It's not even big enough to have an index of 2, so we would actually get an error. But the reason that we don't do that, we don't say right at I is equal to array at I, is because we have to start at the beginning of right, and that index is 0. So, okay, what can I do instead? Well, I can say right at I minus mid. So that is how I take care of that situation. Because initially I is going to be equal to mid, and then I will be 1 larger than mid, and so that's going to give us this correct progression of indices for whatever our right subarray is, okay? Okay, so we're making good progress. We've successfully divided, okay? Now, what's the second step in merge sort? This is done. The second step is to sort. So I'm going to take a recursive leap of faith. Okay, I love taking this recursive leap of faith in merge sort. It's just so wonderful. We can just take a recursive leap of faith and call merge sort on the left and assume that that's going to take care of merge sorting the left. Okay, and then we can take a recursive leap of faith on the right and boom, sorting is done. It was that easy thanks to the recursive leap of faith. Now, what's our last step in merge sort? Well, merging. And remember, while we're writing merge sort, we're going to just assume that merge is already implemented, okay? So we want to call merge on what? Well, we want to call merge on our original array, our left half, and our right half. So merging is done, and we have completely written our merge sort function. Okay, so now that we have worked on our merge sort function and that's all finished up, we can actually start writing the merge function, okay? So let's look back here and recall that we called merge on the original array, the left, and the right. So the skeleton code, so we're taking in, let's say that we have this. And actually, you know what? I don't want to use that as my example, okay? Let's say that we have let's say that this was the input that we got, okay? What happens first? We divide, right? We divide, and we have a left and a right subarray. Then we called merge sort on these subarrays. Now realize that that's going to break it down even further, but for the sake of, not writing out a million things, I'm just going to kind of jump ahead a little bit and just do the actual sorting without writing out all of the dividing, okay? So now I have a sorted left and a sorted right. Now, what needs to happen is I need to in some way merge these sorted subhalves, okay? So how do I do that? Well, I'm going to go element by element and kind of check and compare, okay? So remember, we are supposed to modify the given array, okay? So I'm going to check the first element of the left and the first element of the right, and I'm going to ask myself which one is smaller. And it turns out that 1 is smaller. So I'm going to put 1 right here, okay? And now I've already used this up. So I'm going to compare the next element of the left subhalf and the next element of the right subhalf, which is still 2. So I'm going to compare 2 and 3, and 2 is smaller. So I'm going to replace, and now you guys are kind of seeing the pattern. Well, 3 is the appropriate selection, and finally 4. So that's what's going to happen when I'm trying to merge, okay? So we need to write code that is going to allow us to achieve this. Okay, well, we're going to start off by keeping track of the lengths of the left and the right halves. So they did that. They said int length left is equal to left.length, right underscore length is equal to right.length. They have also created 3 pointers, an array pointer, a left pointer, and a right pointer. The array pointer is going to keep track of where we are in our original array, okay? At what index are we currently working on adjusting? That's what the array pointer is for. The left pointer is for the index of the element in the left subarray that we are currently examining for comparison and eventually assignment purposes. And same for the right pointer. right? Comparison and assignment purposes. Now, while left pointer is less than left underscore length, or right pointer is less than right underscore length, if left underscore pointer is less than left length, and right pointer is less than right length. Okay, so let's really quickly try to figure out what that means. That means that, sorry, one moment, please. I just want this to be a little more clear. That means that we are at, in both of the subarrays, we are at elements in those arrays, basically. Okay, actually, I'm sorry. Let's do this differently. That doesn't make any sense. So the length of this is okay, so what does it mean if my left pointer is equal to 2 in this case right here? Well, at first my left pointer is going to be equal to 0, and then it's going to be equal to 1. And if it's equal to 2, then that means that I don't have anything left to compare within that subarray, right? Because there's only a 0, a 1 for the indexes in the left subarray. And once I get past that and I get to 2, then that means that I've already taken care of all of the elements in the left subarray. So if left pointer is less than left underscore length and right pointer is less than right underscore length, that means that I have elements within both of the subarrays and I can make a comparison, okay? So I now need to actually do that comparison. And I'm going to do it like so. If within the left subarray, the next element is less than or equal to the next thing within the right subarray, then what should happen? The thing within the array at the position that I'm currently working on should take on the value of the thing within the left at that point. And then I need to increase both of these pointers. Okay, now what is the other case? Well, the other case is that the thing on the right was bigger. So if that happens, then I instead need to make the assignment like so. And I will do a similar increment, but not exactly the same. Okay, now what are my last what could go in here? Else, if, and else. So, else if. Okay, so both of these cases, both of these else and else if cases are going to address the situation in which we've ran out of elements in one array, in the left subarray, we've already placed all of those elements into their correct positions, or within the right subarray, we've already dealt with all of those. Okay, so we're going to say else if left pointer, if the left one is the one that still has items in it. In that case, then we are going to make the following assignment. And then we will once again do this increment. Whoops. And lastly, what is our final other condition? Well, our final other condition is the situation in which the right subarray still has remaining elements. And this is what we will do in that situation. Okay, so I hope that this video was helpful, and that is how we write the DIY merge sort function. So first, we went through and we did merge sort using the principles of first dividing, then sorting, and lastly merging. And then we went through and we actually created a function that does the merging for us.